Hello everyone, welcome to today's video. In this tutorial video, we are going to learn how to use Python to create a heat map. By creating the heat map, we can display the correlation coefficient between any two numeric variables in a certain dataset. In today's exercise, we choose the wine quality dataset so that you can learn how to create a heat map. We choose this dataset because this wine quality dataset contains a lot of numeric variables. So we are going to show the creation of the heat map so that any two variables such as this residue sugar and pH, how these two variables are correlated. So let's talk about the correlation coefficient. What is the correlation coefficient? By definition, the correlation coefficient represents a measurement that is showing the linear strength between two variables. And its value can be from -1 to +1. So if the correlation coefficient between two variables is -1, that represents these two variables are in the opposite correlation or negative correlation. One increase, the other one decrease. However, if the correlation coefficient represents a 1 or a value that is close to 1, they are in a strong positive relation. That means if one variable increase, the other variable also increase at same degree. So let's stop share these slides and go to the Python Colab. So let's talk about how do we create the heat map by using Python. Okay, so this is my notebook, and I already import some libraries like the pandas, matplotlib, seaborn, and NumPy. So we're going to use these four libraries to create the heat map. Of course, we need to upload the dataset. And this dataset is about the wine dataset. So I'm going to choose this wine quality CSV. And I also attach the link of the dataset in the video below in the description box. So you can download and play with that dataset. So let's first define a data frame, and that equal to pd.read CSV and wine quality.csv. This is a public data set. So let's take a look at the data set and look at those variables. Okay, so by using the df head, we display the first 5 rows of the data set. We can see that the data set contains a fixed acidity, all these chemical or this residue values, right? And finally, the last column represents quality. The quality represents the wine's quality. We have different level of the quality. So let's take a look at how many different levels in this wine quality. In order to do so, we're going to use df, and we're going to choose the last column quality, and we're going to use value counts. Those value counts can give you a little summary of these, the certain row, the certain column, the quality, and what are the frequency for each different labels. Okay, now this is a little summary. We have, quality from 3 to 8. 3 is the least quality of the wine, and 8 would be the highest quality of the wine. And their corresponding frequencies. So you know that in this data set, we have 681 wines that belongs to quality 5, and 10 of the wines belong to quality 3, etc. So in this tutorial, we're going to learn how to display the heat map to show the correlation coefficient between any two variables. So in order to do that, so let's first extract all the numeric variables. in this data set, we have numeric variable from fixed acidity all the way to alcohol. I exclude this quality because quality, even though this column represents different values, but this value actually denotes a certain label. So you can think this quality as a categorical variable because each category represents a different quality of the wine. So technically, our numeric variable would involve fixed acidity all the way to alcohol, but not the quality. So let's extract all the numeric variable. So I'm going to say extract all the numeric variables. Okay, so all the numeric variables would from the first column all the way to the 11th column, alcohol. Okay, in order to extract all the numeric variables, I would define a variable called numeric df. And this numeric df is a new data frame that holds all the numeric values. And that equal to df.ilog. And this ilog is going to select rows and columns based on the df data frame. So we need all of the rows, but for columns, we're going to need from 1 to 11th column. So because the index is from 0, so I'm going to put 0 to 11 here. So let's check out the numeric df. What is this new data frame look like by using head. So if I execute these two lines, we can see that this numeric df is just a partial of the data set from the df, right? Just we exclude the last column. And the variables from fixed acidity, volatile acidity, all the way to alcohol. So these variables are our numeric variables. And now we're going to compare any of these variables and to calculate the correlation coefficient. If you know the statistics, we know that the correlation coefficient between two variables are very difficult to calculate. We're going to do a lot of mathematical operations, but luckily in Python, there's a function for you to automatically calculate any two variables in this data set. And you're going to have a matrix, and this matrix, each entry represents the correlation coefficient between two any variables. So this function is called CORR, and we're going to attach that function to our target data frame. So this target numeric df is our target data frame, right? So we're going to attach to CORR function, and this CORR function helps us to calculate each every variable pair's correlation coefficient. And once we complete all of these pairs and the correlation coefficient calculation, we're going to put that into a matrix called CORR. Okay, so this is a variable that we defined by ourselves, and this CORR includes an entire matrix and denote the correlation coefficient between any two variables. So let's take a look at CORR and what this CORR look like. So I'm going to execute these two lines, and you can see this is our big matrix. So fixed acidity with fixed acidity, fixed acidity with volatile acidity, fixed acidity with citric acidity, and all the way to the alcohol. And this, this is symmetric matrix, and each entry represents a correlation coefficient between two variables, like the rows and columns. Okay, now once we have this correlation coefficient matrix, how do we visualize that? Remember, we want to visualize this matrix so that you can better communicate with audience, and you can better offer a visual, the color, the gradient color to represent the linear strength between each two variables. And that's why we use a heat map. Okay, so now we're going to develop a heat map. And luckily in Python, SNS library, the Seaborn library contains a function that is called heat map. And in order to create a heat map, all you need to do is to pass a matrix to it. And this is our big matrix, right? So we pass this matrix to this heat map, and that's done. And then we will say plt.show to show the result. So let's find out what happened when I execute these two lines. Okay, now this is a small heat map, and this heat map is just a visual version from the matrix we just created, CORR. Okay, now we have the different colors to represent different values, and you know that the diagonal of the matrix is 1, right? So when it is 1, you have the lightest color. And here on the right side of the bar, the color coding represents different values. Okay, so I'm going to improve this graph a little bit. So we only use the heat map, CORR, and the PLT show. This graph can be elevated by, change the styles and change the size. So let's take a look at how do we change the size. It's very simple. We use plt.figure function. And this figures function, inside of it, we can see figure size and equal to, let's say, 8 by 8. Okay, let's rerun the code. Now you can see the heat map is larger and in the canvas. But when we use the figure size, when I execute these 3 lines, you can see that the heat map, each entry or each box is not square. It's just rectangular, right? Rectangular shape. I want to show this box to be a perfect square. So in order to do that, I can change the argument in this heat map function. I can see square equal to true. When I set a square equal to true and rerun the code, you can see that each box in our heat map is a square. It's a perfect square. It's visually more appealing. Okay, another issue would be the color coding. When we execute these lines, Python would just automatically set the color coding for us. So in this example, we can see that when the correlation coefficient is minus value, it would be the dark color, and if it's a positive value, it is a light color. I want this color code to be reversed version. If it is a 1, 1 represents correlation coefficient, the largest correlation coefficient. I want that box to be the dark color. And on the other hand, if the correlation coefficient is 0, and that would be the lightest color, and then reverse the code. Okay, in order to do that, I can set the color map. So in order to do that, we can call CMap, and the CMap equal to a certain color map. And I know that crest would be the perfect color coding for us. So let's rerun the code. Okay, so this is another color map. When you run the code, you can see that the entire color coding is changed. And you can type the CMap and search that in the web browser. Choose color maps in Matplotlib. So I'm gonna choose the diverging color on both sides, like this one. So I'm gonna use this one, BWR, and yeah, this would be better, right? So if it's a positive one, then it would be the very bright color, and if it is a negative one or negative value, that would be the very dark blue color. This is a divergent on the both sides of the value. Okay, so this is how we change the color map so that we can better visualize those values. And another thing I want to change is the range, the value range. We know that correlation coefficient, the value is from -1 to +1, right? The +1 would be the largest correlation coefficient, and the -1 would be the smallest. But take a look at the color code in here. Take a look at the value range in here. The value from -0.6 all the way to +1. So I want to reset the range from -1 to +1. In order to do that, I'm gonna add another 2 arguments in this function. We're gonna say Vmin equal to -1. This is our lower boundary, and the Vmax would be the +1. So Vmax and Vmin is help us to set the lower boundary and the upper boundary. And let's rerun the code. Okay, now you can see the value range would become -1 to +1, right? So this is better. You can see the color corresponding its value, and it's overall spreading between the +1 to -1, and it's just it is a better way to show the correlation coefficient between any different variables. Okay, and another issue I have is that take a look at these boxes, and we know that there is no boundary between boxes, right? In order to have a clear boundary between the boxes, I would say line width equal to 0.5. So if I add this value, very small value 0.5 to this line width, and I just give a little boundary between all these boxes so that you can better visualize those correlation coefficient. So let's rerun the code. And now you can see that the boxes and the line between these boxes has been, the distance would be a little bit further so that you can clearly see what is the value in here and to separate those boxes. That's it. Okay, so this is the correlation coefficient matrix and how we visualize this correlation coefficient matrix by creating heat map. So let's take a look at this heat map, and you can see that the upper triangle and the lower triangle would actually be symmetric. Why? Because the correlation between any 2 variable is the same when the order is reversed. So that being said, if we want to show the correlation coefficient, we can actually use a half of the triangle to show all of the correlation coefficient, right? We don't need the whole matrix. We only need the half matrix. But how do we visualize the half matrix? How do we just cut the upper triangle and only preserve the lower triangle? So I'm going to introduce a way to do that. And before we cut the half matrix, we're going to define a matrix that is called matrix, matrix, and that equal to np dot triu. And this numpy dot triu function will return you a half of the matrix. So in this function, we're going to pass CORR. Remember that CORR is our big matrix. This is the value we're going to visualize upon, right? So when pass the CORR to this numpy triu function, we're gonna this will return a half matrix and store that to matrix. So let's take a look at what matrix looks like. Okay, now you can see this is the returned result, and it's only represent the upper triangle. Okay, we're gonna use this matrix to be our mask to hide this upper version and leave the rest of the lower triangle to be visualized. So let's take a look at how do we do that. So now we have this half matrix. So actually, you know that matrix is only the half matrix of the CORR, right? And now we're gonna create another graph. So we're gonna say plot dot figure, and we're gonna set the figure size 8 by 8. Figure size equal to 8 by 8, and we're gonna create a heat map. SNS dot heat map, and of course we're gonna use the entire matrix, but this time we're gonna use this matrix as a tool to facilitate the half heat map creation. So first we're gonna pass the entire matrix, and then we're gonna set another argument in this function called the mask, and this mask equal to the matrix. So let me explain why do we use these two arguments here. First, CORR is a matrix we're gonna visualize upon, and when we set mask equal to matrix, we're gonna cover the original full matrix by the half matrix. So you can think that mask is like a scissor, that it's like the scissors you can cut the original CORR into half. Okay, now let's take a look at how this happens when I show the result or execute these three lines. Okay, now this is how we cut the upper half matrix and only reserve the lower half matrix. Okay, of course, for the style setting, I just copy the original one we set in the previous code. So we copy the style in this heat map function, square equal to true, CMap equal to BWR, and this is lower boundary and upper boundary, and line width equal to 0.5 to separate those boxes. So let's rerun the code. Okay, this is just the same exactly style with the previous one, but the only difference is that we cut the previous matrix into a half so that you can better show the correlation coefficient with more space. Like you can utilize this half space to put some text or adding some other figures you like, right? And lastly, I'm going to show you how to add those to annotate the values. We know that so far the box or the color of the box represent a certain value, and you can corresponding this color to a certain range in here, but we don't know what exactly the correlation coefficient in that box, right? So in order to give annotation for this certain particular box, we're gonna say annotate, and this annotate represents the annotation for a small box, and that equal to true. So let's rerun the code. Okay, a little typo. Okay, true, and then let's find out what happened, right? If you set annotate equal to true, you can see that each box will return you a value of correlation coefficient between certain two variables. And this is how we use Python to create a heat map and adjust the heat map style as well as leaving the lower triangle for the visualization. And I hope you enjoy this video, and I will see you next one. Thank you.